All right, we're going to be looking at lesson 2 of our set theory unit, and we're going to be talking about Venn diagrams. So far we've looked at kind of what is a set, right? What is a subset? What are those elements of that set? And how might they relate to other sets through things like intersection, union, are two sets disjoint, things like that. Well, a Venn diagram is really just a visual way to see those relationships of elements between sets. So what we can do is we can kind of categorize, we can visualize what elements fall into what sets, where there may be overlap, where things might be disjoint, things like that. So to start us off, we're going to talk about the universal set of natural numbers less than or equal to 20, and then a couple of subsets of that. So, right, remember natural numbers starting at 1, we're not including 0, 2, 3, 4, right? This one says it's going to go up to 20, so 18, 19, 20. We're going to talk about set that we're calling set A, where A is all of those natural numbers less than 20 that are divisible by 2. So I start to think about some of the elements of this set. Well, 2 is divisible by 2, 4 is divisible by 2, 6, 8, right? I'm going to get all those even numbers, 12, 14, 16, and 18. I'm not going to have 20 because notice here it says numbers that are less than 20. It does not say less than or equal to, so I can't actually include 20. Even though 20 is part of that universal set, A has a bit more of a specific requirement on it. B, on the other hand, is the natural numbers less than 20 that are divisible by 3. So now 1 isn't divisible by 3, 2 isn't divisible by 3, but 3 is. And 6, 9, 12, 15, and 18. Those are all of the numbers that are divisible by 3, or that 3 is a factor of, right? So, looking at a Venn diagram here, looking at a visual representation, I have overarching my universal set, right? It encompasses the whole of A and B because A and B are subsets, right? A and B are sets made up of only the numbers within U. So those circles representing A, right? Over here we have set A, and over here we have set B, right? Those circles are completely contained within U because all of the numbers in A and B are in the set U. Let's start to think about where some of these numbers in these sets are going to fall into this kind of diagram. All right, so let's think about all of the things that aren't inside A and B first. So numbers like 1 and 5 and 7 and 11 and 13 and 17 and 19 and also 20, right? All of these numbers are not inside A or inside B. So they can't go within those circles of A and B. They're not part of those sets, but they are still part of our universal set. So they're in this overarching outer box, but they're not inside of A or B. A has a few numbers, right? A has 2 and 4 and 6 and 8 and 10 and 12 and 14 and 16 and 18. Notice that 6, 12, and 18 I wrote over on the right side of A, because this middle section here is where A and B overlap. So this space is reserved for only those elements that are inside A and inside B, right? So 6, 12, and 18 are those numbers that were in A and are also in B. However, B has a few more elements. B has 3 and 9 and 15 that weren't inside A. So they don't show up in that middle section. But if I was to, right, focus in on and just look at what's inside B right now, inside this circle, I have everything I need. I have 3, 6, 9, 12, 15, and 18. If I then take a second and look at A, inside this whole circle called A, I have everything I need, 2, 4, 6, 8, 10, 12, 14, 16, and 18. The things that overlap in A and B are in this section where their two circles or their two sets overlap. So 6, 12, and 18 are the only shared numbers between set A and set B. And all of these numbers 1 through 20 are fully contained in this outer set U, right? All of the numbers 1 through 20 show up somewhere because they were all part of set U. I just want to make sure they go in the best possible place, the most specific location, right? Yes, 6 is part of A. So 6 could show up here. But then if I needed to also say 6 is part of B, I don't ever want something to show up more than once when it wasn't prevalent more than once, right? So 6, I'm going to put it here in the middle because that does both jobs for me. It says 6 is a part of A and 6 is a part of B, and that way I'm not double counting 6. All right, so take a minute and try the next one. So thinking of that same universal set, right? Natural numbers less than 20, and including 20. Think about the numbers that are multiples of 3, right? Think about the numbers that are multiples of 5, and then see if you can arrange them in a Venn diagram, right? Keeping in mind some of those key areas, right? Everything that goes in this middle section has to be in both A and B. Anything that's in A but is not in B is going to go in this left kind of crescent moon shape. Anything in B that is not in A is going to go in this right side. And anything that doesn't fit into A or B, but is still part of that universal set, is still a natural number less than or equal to 20, goes in the outside. All right, so I have my sets here, right? A, same as B was in the last example, 3, 6, 9, 12, 15, and 18. Set B, multiples of 5, we have 5, 10, 15, not including 20 because it didn't say less than or equal to 20. The way I might start this is say, well, what do they have in common first? And I'm looking at A, I'm looking at B. Well, the only number they seem to share between A and B is 15. Where's that going to go? That's going to go in this middle section where A and B overlap. Then I can ask myself, okay, well, let's fill in the rest of A and B. 15 has already been covered. B still needs a 5 and a 10. And I can just write those anywhere in the circle. A still needs a 3 and a 6 and a 9, a 12, and an 18, right? Remember, I'm not writing 15 again because with it being in the middle already means it's part of both. Then I'm going to go through, think about that universal set, anything I haven't listed. I haven't listed a 1 or a 2, a 4, I have 5, I have 6, no 7, 8, no, we have 9, we have 10, no 11, we have 12, 13, 14, 15's right there in the middle, 16, 17, 19, and 20. So again, every number 1 through 20 can only show up in one place, right? Because we're only talking about those numbers once in this whole universal set. We just want to say, can I be more specific? Can I take a number and move it into another set, right? And is it actually even shared between multiple sets? So let's talk a little bit more specifically using some of that terminology we covered in the previous lesson about where these terms like intersection, union show up in a Venn diagram. All right, so the intersection of sets. So remember, that's what this symbol is kind of upside down U. That means I'm only looking at the elements that are members of both set A and, keyword and, set B. And in this case, the intersection is exactly what it sounds like. It's where my two sets intersect. Anything in this middle section here is things that are part of A and part of B. So this area here is A intersect B. The union of sets, right, where it's elements that are members of either A or set B, or both, right? That's something that is part of set A, which is this whole circle, or part of set B, which is this whole circle, or both, which includes the intersection. So as long as it's in either of these two circles or where they overlap, and it's just not, right? Essentially, it's not out here. right? It's not part of neither set. It has to be part of one or the other or both. This whole area is A union B. And then the complement, right? So A prime, right? I could also talk about the complement of B prime. This is the set of elements that are not members of set A. So this one is anything that isn't in that circle A. So it could be part of set B. However, it can't be part of set B and set A. It's not in that intersection. It's just in that external part of B. Or it can also be outside of set A or B completely, right? So part of that universal set, but not specifically part of set A or set B. Essentially, it cannot enter this circle, right? It can't be any part of set A. So that would be A prime. Any element in this colored area would be part of A prime. So in each of the following regions, let's shade the region described by the set. So set A, right, again, this circle, including the overlap, everything that falls into here is part of set A. So I can shade the whole outer circle. I can also shade that overlap with B, because that still means it's part of set A. Set B prime, right? This is everything but B. Let me write that. Everything but B. So now I'm just making sure I'm not shading inside that circle B. It can be in set A as long as it's not part of the intersection. Right? And it can be part of the universal set, but not part of set A or set B. All right, so everything outside and everything that's exclusive to set A is part of set B prime. Set A intersect B prime. So this is where everything in set A intersects with everything in set B prime. So essentially, where do my first graph on the top left and my second diagram, right, or my second Venn diagram on the right, where do they overlap? All right, so I'm saying I need things that are part of set A and also not part of set B. And the only place here is this exclusive section of set A. So the left side here, this crescent moon shape, because these are things that are part of set A, and this is the only thing that is part of set A that isn't part of set B. As soon as I approach this middle area here, yes, it's part of set A, but it wouldn't be part of B prime because it's in B, right? And then this last one, set A intersect A prime. So I'm now looking for things that are in set A and, right, that intersect. We can use the word and. Also not in A. Well, does that make sense? Can something be in A and also not be in A? Well, no, right? Because A and A prime are exact opposites. So this would be the empty set. There's nothing shared between A and A prime by the definition of A and A prime. So I can say nothing shared. Right? Not everything has to intersect. Things can be completely separate, and the definition of a complement is that it is completely separate from A. All right, so we're looking at the following sets. We have the universal set 2, 3, 4, 6, 8, 9, 10, 11, 14, 15. We have set A, which is a subset, 3, 6, 9, 12, 15. And we have set B, 2, 4, 6, 8, 10, 12, 14. Right, so it looks like A, multiples of 3, B, multiples of 2, are subsets of this universal set. So let's illustrate these using a Venn diagram. Let's take these values, these elements of these sets, and put them in their place. So I'm going to start with set A. Right? I'm going to look in set A. I'm going to start to fill in these values. Every time I'm putting in a value, I'm going to ask myself, because A kind of has two portions. There's the part of A that is strictly within A, And then there's the part of A that's shared with B, the intersection, right? Remember this section here would be A intersect B, so the things that they share. So as I go through the elements of A, I'm going to cross them off as I write them down. So A has a 3, A has a 6. As I'm looking, I'm going to ask myself, I'm going to reference, I'm going to say, is 6 also in B? 3 wasn't, so I went ahead and put it in A. 6 is shared between A and B. So I'll cross it out of both so that I don't accidentally double count it. And I'll put it in the intersection. And then I'll keep going. 9 is in A, but not in B. 12, right? I check B. Oh, it's in both places. I make sure it goes in the intersection. And 15. So, oops, there is 5 elements in A, right? I can see all 5. 1, 2, 3, 4, 5, right? And they've all been included. B, now I've kind of already crossed out what I've already put in that intersection. So I still have to put in just B alone 2, because it wasn't shared with A, 4, 8, 10, and 14, right? Double check 2, 4, 8, 10, and 14. Right? And I could check that as well. There was 7 elements in B. In this whole circle labeled B, I have 1, 2, 3, 4, 5, 6, 7 elements. Right? 2 things fall into that intersection. 5 things are exclusively in B. Then I look at my universal set. I had 2, which I included. I had 3, 4, 6, 8, right? I could do this while I'm going along as well. 9, 10, 11, 12, 14, and 15. And there's actually nothing in U that wasn't in A or B. So that means this space is going to stay empty because everything that's in U falls into these subsets of A and B. So here's our Venn diagram. All right, we have all of our elements included in A and B. Now let's talk about the elements in these following sets. A prime or A complement, right? I'm asking what is not inside of A. So if this whole circle, right, including this intersection area, this whole circle is what makes up A. I'm just looking for any elements outside of this circle. So in this case, it's going to be everything that's strictly in B. So 2, 4, 8, 10, and 14 are all of the elements that are not in A, but exist in this universal set. B prime, right, or the complement of B. Oops, I'm circling the same circle. Now I'm saying, all right, what elements are outside of this circle, outside of set B? And that's going to be 3, 9, and 15, those 3 elements that are just part of set A. A intersect B. Now I'm asking what's in the overlap, right? What's part of both A and B at the same time? So that's 6 and 12. A union B. So that is everything that is in just A, everything that is in just B, and everything that is in just A and B. So really, in this case, it's everything in that universal set. So I can list everything. 2, 3, let me look at the list, 4, 6, right? Or I can reading them from up in my chart here. 2, 3, 4, 6. We have an 8, 9, 10, 12, 14, and 15, right? Or we could say that's equal to U because it is equal to the universal set. It was every element of that universal set. All right, A intersect B prime. So where does A overlap with things that are not in B? Well, I'm saying where does A overlap with things that are not in B, which is exclusive to A and, right, anything that was outside in just the universal set. So it looks like those two locations of overlap, where do the pink and the purple overlap, is again these three elements of A. So 3, 9, and 15. A prime, right? The complement of A intersect B. So where does everything that isn't in A, right, which is strictly B plus the outside, where does this intersect with things that are just in B, right? And again, in this case, things that are strictly B. This area here is going to be A prime intersect B. So we had 2, 4, 8, 10, and 14. All right, so make sure you're understanding where all of these elements are coming from, how we can tell where they fall based on that visual representation. Let's talk a little bit about how many elements are in some of these sets as well. So the number, right, remember n of set name is asking us how many, not what are the values, not what is in the set, just how many elements are there. So n of A prime, well, we had A prime up here. I had 1, 2, 3, 4, 5 elements in that set. Or I can look up here, know that this area was A prime, right, the complement of A, and there was 1, 2, 3, 4, 5. Right, so I have 5 elements. That tells me that n of A prime, A complement, is 5. The number of elements in A union B, right, well, we had that here, number 4 up above. I can just count those elements. 1, 2, 3, 4, 5, 6, 7, 8, 9. There is 10 elements there. Number of elements in A prime intersect B. That was this bottom one here. 1, 2, 3, 4. There is 5 elements there. Right, so again, it doesn't matter what elements, it doesn't matter the value of the elements. All we care about is how many distinct different elements there are. Oops. All right, so take a minute, give this next one a try. You again have a few sets, right? Universal set U, you're gonna look at subsets A and B, and you're gonna figure out where those elements are gonna fall in terms of this Venn diagram, and then answer a few questions. All right, let's quickly recap this last example here for Venn diagrams. So set A, we had 1, 2, 8, 9, and 10. So we have 1, 2, 8, 9, and 10 showing up in set A. Set B was 1, 7, 10, and 29. So we have 1, 7, 10, and 29, with that 1 and 10 being our intersection, right, shared between A and B. And then this time we did have a few stragglers that weren't part of A or part of B, but were in our universal set. And that was the 11 and the 16, right? Because they didn't show up in A or B, but we still have to include them. They were still part of that universal set U. Thinking about some other sets, A prime, the complement of A, anything that is not inside this bubble here, A, was those things in exclusively B, so 7 and 29. And those things outside of A and B, so 11 and 16. B prime, same idea, but now I'm getting the 2, 8, and 9 from outside B, as well as the 11 and 16 from outside both sets. A union B complement, so these are things that are in A or not in B. So that includes everything in A, including the overlap, because this is an OR, right? This is a union. So I'm taking everything that is in A, regardless of any other rules. Then I'm going to say, okay, moving on. Now I'm going to take anything that isn't in B, that I haven't already taken, because I already counted the 2, the 8, and the 9. The 1 and the 10 were part of A. The only things left that aren't part of B, right, that are in the complement of B, are 11 and 16. A prime, complement of A, intersect B, right? These are things that are not in A and only in B, leaves us with just the 7 and the 29. Then we can talk about some values. How many elements are in B prime? Well, that was this set here. Looks like there is 5 elements there. How many elements are in A intersect B? That wasn't one of the sets we counted, but it is this middle section here. Right? Remember, this middle section is always the intersection. This is A intersect B. Right? And I see 2 elements there. I have a 1 and a 10. And then the last one, how many elements are in A intersect A prime, right? How many elements are both in A and not in A, right? This is a disjoint set. I have the elements in A, I have the elements that are not in A, which is everything outside. There is no overlap. So I have no elements, right? So that was the ideas of Venn diagrams. Feel free to do some of the practice on D2L to make sure you are understanding these concepts pretty well. If you have any questions, send me an email. These notes are posted on D2L, so if you need to go back, check anything, feel free.